Alright, so begins another draft physics video presentation. Yeah, okay, we'll get on with it. Ugh, so much work. I did notice something sort of irritating. I just thought I'd mention the Holiday, who had changed his name, which is sort of irritating. But anyway, whoever's his son, I guess, privatized or whatever, unmade public all of his videos, except for the last 15 or whatever. I just don't really understand that. I mean, in his last word little speech, he talked about how much he enjoyed the years of confrontation and whatnot, interaction, and all that mush, and so I just don't see why they would destroy his sort of legacy of content. Just don't understand where the motivation for that came from, but whatever. So just kind of just throwing a little warning in there. I haven't even done enough of this. It's a good idea to write down what you want done after you're dead. What you want somebody to preserve and what you don't care about and all that kind of stuff. Because I don't think people get that stuff right too often, frankly. Yeah, they don't really honor the dead too many times because they do things that the dead guy would say, hey, don't do that. Or vice versa. Anyway, just saying. As I say many things. So I guess we'll do some comments and then maybe we'll do a Sabine Hassenpfeffer bullshit on dark energy, which should be quite hilarious. But anyway, may the forest bits be with you. Okay, so some kind of joke. There is some value to be gleaned out of Star Wars. Movies have plots and themes. They're always kind of formulaic, and so there's always something of value in there. But I'd say the force be with you kind of crap, obviously that just has to do with the mystical part, like somehow you can, manipulate the universe with your thoughts, your good feelings. And so that part was kind of bullshit. It's like Spock doing the live long and prosper thing, instead of some more rational statement like, I hope everything goes okay, I wish, good luck, or some kind of silly thing like that instead, because it just, what is this? What does prosper mean? Fulfill your productivity quotient would be a better thing to say, maximize your productivity. Live as long as you can tolerate and maximize your productivity. That would be a much more Spockian kind of statement than this prosper crap. What's prospering? There's no way to prosper without fucking something over, or fucking something, literally. And what does that whole thing entail? Well, whatever. The whole thing is like Vulcans would bother with marriage. Come on, get real. The whole thing was stupid. But anyway, I mean, they just didn't do logic very well on Star Trek. It's very nice themes, very nice, gooey, human, emotional, this kind of shit. But, they really didn't do what logical beings would be like. They'd be a lot crankier than Spock was. Anyway, half human, you see. The big flaw in the Spock. But anyway, the Vulcans were emotional basket cases. We've abolished emotion, except we're hateful, petty, snobby bastards. That's emotions, asshole. Anyway, moving on. I mean, I don't know what to say. Okay, you want to make jokes? Thank you. I love the trivialisms. They help so much. They make me just feel all gooey inside. No, I think I'll delete it because, fuck this trivial crap. The fact is, the world's being run by fucking imbeciles full of shit, okay? Selling crappy, stupid, ludicrous ideas that can't fucking goddamn work. It's all over our politics. They don't fix all the unsustainable shit, the stupid fucking facts that are right in their face they don't give a fuck about. And then here the scientists, the smart intellectuals, are all chasing these stupid, idiotic fucking rainbows. It's really a serious problem, Anyway, everywhere I look, I keep seeing and hearing the line, physics is not answering questions about why the universe works the way it does. It's only meant to explain how it works. Well, it doesn't do that, so I don't even hear that all over the place. I hear this excuse, that, um, we predict things that we already saw and we already know happened with our math, sort of. Well, most of the time. Well, it works as long as you have all these right conditions. It works. All right, well, whatever. Whatever. Anyway, the fact that I keep encountering these lines over and over again shows me just how dogmatic people are, even when they're supposed to be scientists. I don't even know if dogmatic's the right word, but because I don't want to make it too many associations with actual religion. But I guess it has every association with the origins of religion, which is, jump to the bizarrest conclusion possible. I imagine in the primitive times there was some caveman, who was saying, "Ugh, world look rocky and stupid," and then, but all the others were like, "No, let's go for the world created by Super Ugg, who doesn't wear smelly skins and lives in a little paradise covered in rubies." And they went for that crap story instead. But I mean, it's this whole, let's just jump to a conclusion. Let's not really think about it for a while. Mull it over. You don't do enough of that mulling over stuff. Anyway. Whatever. As Scott Steffen touched tangentially, there is the physical reality, and then all kinds of human explanations for it. Yes, and that's the problem, is that the explanation should be in the realm of reasonable. Okay, something that's well supported, not unwell supported by evidence. And again, it's okay to believe something. Just temper your belief with the acknowledgement that, well, this ain't ready to write in stone. Some things you can write in stone, as I've said millions of times before, and some things you can't. Some are made up entirely. Some are at least a little anecdotally based on some, and some are probably correct. Well, whatever. I think a lot of them are correct. So, it's just that these certain major ones are just loop-de-doo nonsense, like space makes things move. Well, whatever does it, it ain't going to be called a space. It's just silly to call it space, okay? That's just stupid. Call it pixies or gremlins. All right. What did you say that in? Like anecdotally based? Yes. Well, it's this idea of similar. It looks like. That's the thing you got to really be careful of, and that's the thing. Physicists have lost all sense of notion that they can be fooled by the little magic tricks. All right, I don't adhere to a single theory yet. Well, I'm saying there's so much fucking evidence, I don't see why you don't adhere to certain concepts with some kind of feeling kind of comfortable that, yeah, the world isn't made out of wooey magic. We don't see it anywhere. We don't see anybody grow a new arm, right? We don't see anything violate this cause and effect chain that has to take place. And there's absolutely no reason to think all these little magical properties exist. All the ESP and all the special force powers all exist in the tiniest things in the universe, which would be the simplest and the most rudimentary in their function. I think you can be really quite certain that's the way it works. It gets simpler going down, not more complicated. The complicated stuff takes time. Lots and lots of interactions over lots and lots of time before you can sit there and make, pile one of the dice on top of the other dice. And, you can sit there and just bounce dice on the ground, and have them just pop, land in a location. You could just sit there for 1,000,000 years throwing the dice and trying to bounce and get the dice to stack up, right? One on top of each other. It would take you damn long. You could do it though, right? Theoretically, there's nothing in the way, really, from you getting it just right. The spin on the dice and, to lob it up there and have the dice just land so softly on top of the next dice. I don't know about there's probably a theoretical limitation to how high it can go, certainly. How many dice you could pile up. But yes, it can happen. But the dice are dice. The dice, it just takes a ton of interactions to create anything complicated. And ESP is complicated. Anyway. Because I think the real answer is probably a compromise. Well, I don't think I don't think there's any reason for you to think there's any reason to compromise with the loop-de-doos. I don't think any piece of religion has any hope of being the truth, okay? Even a glimmer of a God exists out there. Not even a few pixels of God. There's just no fucking such nonsense. Of the various conjectures. Now, there's no little bit of many worlds is correct, or little bit of radar is correct. None of that crap has any hope of being the right answer. Even the wild ones, well, I don't know what to say. I mean, you're not grounded at all, so you're just part of the problem in a way. You just tend to think, oh, well, because they can make up a story, it must have a grain of truth to it. So there must be a little bit of invisible man in the universe, because I can imagine an invisible man, so there must be invisible man, so let's compromise with the invisible man theory. No, let's not. As well as the obvious parts. Well, if there were obvious parts, then we wouldn't be in so much trouble. I guess that's, I wish it was, obvious is a term, right? I think it's obvious, but obviously it's not obvious by any kind of, well, what does the average human do? Like, what does the average photon do, right? So, if you apply an average to it, obvious doesn't mean much, because nobody can seem to do any of this obvious thing. Then again, Mother Nature, which is just a horrible combination of words, is simpler than we tend to think. Well, we got that part right, but I don't know if you got it right for the right reason, because you think it's some sort of compromise to say what is the most probable right answer. And the most probable right answer from our perspective would have to be, yes, it gets simpler going down. That's what the whole universe is screaming at you. The pieces are simpler, the atom is simpler than the compound. It's just kind of obvious. So your theory has appeal to me. Yeah, well, you've already done this appeal thing, which I'm not too... Appeal doesn't really, it's not doing much for me. I think I've demonstrated it's a far better theory than their nonsense. It unifies, and it's simple, and it's mechanical. It wins in every category. It's just should be a conversation I shouldn't even have to make. But based on some personal observations, so this is the part where it gets scary, right? Personal observations, you mean you've talked to your uncle, your dead Uncle Joe, you had a vision. Ugh. Anecdotal bits like, oh, I had a really bizarre coincidence happen to me. Yeah, that happens to all of us. So we've all had really bizarre coincidences. There was a kid when I was a kid who had the same name as me, and he had the same hair as me, and was, very much like me. It was very coincidental. He lived in another town, so, went to jail, and a whole, like half the people I knew thought it was me. What a surprise. Anyway, and pieces. Anecdotal bits and pieces. Yes, well, I don't really want to add, what use is anecdotal bullshit, right? Because that just has to do with the weakness of human psychology. Because we fall for this stuff. You want something. You almost want the world to work where step on a crack, break your mother's back. You almost want things to be that clear. Where, okay, just don't step on any cracks, everything will be all right. We all want that. But it's not the real world. and just a gut feeling belief. Well, why you tell me that? I mean, what am I going to do with gut feel? I have an emotional thingy that makes me a little bit wooey. Oh, great. I am, I am of the mind that entanglement is a reality. Yeah, well, again, do you understand the experiments? I mean, the entanglement experiments involve some idea that, well, you're supposed to get this 75 number, and instead they get an 85 number, for a percentage. And somehow that means they must be entangled because this tiny percentage difference indicates that there's got to be some sort of communication or some, whatever the thing is. And it's this whole experiment done with polarizing filters, which I've already explained. I don't even think they know the nature of them at all. They don't know how they even function. And beam splitters and all of this stuff where I've already pointed out how there is no perfect beam splitter. There's no, well, there probably are ways to do it perfectly, and they don't do it that way because then their experiments won't work because they'll create two actually equal beams. Like you take a pointed mirror and just split the right beam, left beam. That's probably okay. You get two equal beams that way, but they don't do it that way. All right. Let's see. I just don't, well, anyway. So why tell me this? Oh, you have some vague notion that there must be entanglement. Although perhaps not the same kind of entanglement. Well, what kind would it be? I mean, just come on. Okay, they have ESP, but not real ESP. It's something else. Okay, that current mainstream physics has as its potpourri of stuff. In other words, the instantaneous action, which again it is so unintuitive, and it's so, again, it's just such a magical claim. There's no evidence of it anywhere. I mean, if there was any evidence of it, we've already statistically found this increase in probability of because of the fact that the just imagine just even evolution. Why wouldn't evolution capitalize on any kind of instantaneous capacity to interact? I mean, it would create a sense organ that could play this instantaneous game, and then it could know before Jeopardy was going to get to it, that it was coming. I mean, it just whatever. At a distance part is real. But the explanations for it thus far may be fluff. Yeah, well, the evidence for it is fluff. And again, I'm not even, there's no point in me even inquiring as to why. Why would somebody think it's an extraordinary claim. Again, it's sort of like saying, well, in spite of the fact that all the UFO photos have pretty much been demonstrated to be absolute nonsense, and the whole theory of the UFOs visiting and just monitoring and all this other bullshit is just silly anyway. The whole thing doesn't make any sense, really. I'm going to believe anyway. Just my personal belief. We've got I know, but it's really not the point of my existence here on YouTube in any way whatsoever, is to talk about a bunch of fluffy individual psycho problems. And that's sort of what it is. It's a psycho problem. You can't defend it logically. You can't write a theorem or a theory of why there's any realistic possibility except to say, a ghost tripped me once and made me fall into a table full of little statues, and I broke them all, and I felt very embarrassed. Okay, sure. Keep pushing the envelope on this. Why? You're not really encouraging the activity. It's like meaningless because people are just going to sit there and go, the ghost did it. I didn't do it. It wasn't my fault. They're going to keep doing that. It appears. They'll do it right in my face. It seems nobody else is doing that. Yes, it does seem like the world is completely sterile of reasoning and intelligence. It's just, I'm it. I'm the last little bit of, just like there's probably one little bit of smallpox somewhere in a little jar. So like smallpox. Yeah, I'm almost extinct. All right, can't comprehend why that is true. Nobody else is seeing. Yeah, well, you can't comprehend why it's true. Well, it's true because of people like you. You're just wishy-washy. They're all sitting in their little wishy-washy boat. Wishy-washy, wishy-washy. Oh, I don't feel like I want to have a universe that doesn't happy. I want a happy universe. I want it. Blah, 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 blah. They're all doing what do I want to believe. They're not doing what can I defend as a belief. So yeah, they're like you. They're not like me. I guess envelope pushers are different kinds of people. Yes, it appears that way, and it appears I'm the last frickin' one. So when I'm gone, your people are really going to be in a big pile of doomy woo. All right, Superior Mind. There is a huge dollar incentive to make FTL. I don't know what that is. Flat time losers. What is that? FT? I don't know. Communication technology. Oh, faster than light. For if it's for real. Yeah, well, they have this catch that we really can't control whether the entangled photons, they're twins, right? And one's a boy and one's a girl, so they're always inverted. And we can't control the one over here. We can't make him a girl, and we can't make that one a boy. But you certainly could pre-send, okay, instantaneous messages in the sense that you could preload the bomb and then instantaneously trigger it. Okay, anyway. Or even time it for some moment in the future. Anyway, if it's for real, I read over some of the alleged experiments and data collection, and my impression was that there was an overwhelming number of incredible assumptions being made. Yes, the technology is extraordinary in terms of what they claim they're capable of doing. It's like LIGO saying they can measure half the distance of a proton. It can't be real. There's no physical way you can account for that being a possibility just because the noise in your experiment is much bigger than half a proton. You can't overcome the noise. All right. It's like blind people wearing padded gloves trying to argue about something they think they found. I don't get the analogy, actually. I don't even know if I want to sit there and try to imagine blind people, but anyway, fighting with gloves, but whatever. All right, so Tom Spencer. I mean, this is just sort of annoying. No offense, but of course I want to offend people. From particles to waves, the fields of their fields and their connections. You can English translate. No, you can't. You can only translate. You can only put the closed caption into English. And so you got to sit there and go through the whole video trying to read the closed captions. It takes you only 4 times as long. And these are, Spanish videos. They've got substantial numbers of views, 300,000 views. Nobody can do an English translation. So, this is what I find a little bit obnoxious about the foreigners, you people of another world. Come on. All right? English is the universal language. It's the biggest, okay? It covers all the intellectuals anyway. 90% of the smart people on Earth, the educated people, speak fucking English. So if you're going to make a claim of some kind or you're going to say something important in some way, it seems like you should get somebody to translate it into frickin' English. So, sorry, but this is just sort of bullshit. You can't find one English reference to the statements being made. That's just bullshit. Frankly, it's sort of, I would say it's a better version of quantum mechanics in some respects, but it's still got plenty of woo in it. That's not what we need. All right, so Scott Steffen, should be capitalized paragraph, Well, you should be able to break the paragraphs too, even. Electromagnetic waves all have the electric part and the magnetic part perpendicular to each other, and their oscillations intersect together at regular intervals, which is the frequency. They're both moving in the same time, so they're doing this, up, down, up, down, up, down. So they have nodes, yes. You should say their theory of electromagnetic waves, right? Because there is no electromagnetic. But anyway, period, and then you got no capital again. Could be part between every two interactions. Could the part between every two interactions be what we call the photon? No. The photon has to have a length. It has to have a ray length. A photon is a combination, a sequence of nodes. It's speculated again, well, theorized, whatever, that we need like 6 to 9 of the nodes of frequency before we can detect a frequency. So it's sort of like a radio signal. I mean, you have to have enough radio signal for the transmitter to know you're sending a signal, to oscillate at the same frequency, to do all these things that need to get done. So you need a certain amount of frequency before it can say, I got it, I am receiving a frequency. And like I said, different frogs do a little better. Okay, they only need like 3. Maybe a photo detector is, photo multiplier. Who knows? Because those you can turn them up all the way and they'll go off constantly. So they might even be gravity detectors for all I know. But anyway, let's continue. Part between every two interactions be what we call a photon. And since there are 2 parts to that, the electric and magnetic, could these be the 2 force bits in your explanation of gravity? Well, clearly there's a similarity in the sense that I've found out that the only real way you can create attraction and repulsion is to have an inverse relationship between 2 things. You really have to have 2 things, and then you have to have 2 things interacting with the 2 things to create an inverse reaction. I've tried to do it millions of other ways. I mean, I went through every kind of way of trying to make it out of one thing, and with no luck. I'm not saying it's impossible, but I'm just saying that inverse part just sort of necessitates the 2 thing. And the fact that Maxwell bisected, separated electricity from magnetism is really just a byproduct of the fact that they separated polarity. Okay, so they basically made a distinction between charged elements, the monopoles, and a dipole. So they decided to call a dipole magnetism, and they decided to call the monopoles electricity. And that's where it all kind of went foul. Because all they are really is monopoles, plus and minus, and the north and south is just plus and minus smashed together. So the similarity probably ends there. I mean, I'd like to say that you could take Maxwell's abstraction and remake it, but of course you could. I mean, I think Maxwell's is underdone mathematics. It's not right just because of the fact that they bisected the speed of light. It's sort of an obvious giveaway that you have, mu 0 and epsilon naught, or whatever the hell it is, as 2 components that add up to the speed of light. I mean, the equations don't have the speed of light in them. They have this stupid broken, the permutivity of space, 2 made up constants, never measured constants, completely mushy constants. Anyway, so obviously I think it can be unified, but it will require them to grow up and figure out that magnets are made of charge monopoles. The same thing that makes charge makes a magnet. Alright, and since there are 2 parts, could these be the force bits? Could these be the 2 force bits in your explanation of gravity? Well, my explanation of gravity is sort of negating the force bits because the dipoles, the magnetic dipoles, are all pointing in random directions. So there's no charge component. The charge is kind of negated as being significant because the charges are all mixed up and turned into a neutral in a sense. And so gravity is really just the idea that the elements themselves, electrons and protons, absorb momentum. And so they'll still be doing that. They won't do it in a dipole kind of way. They won't do it in a way where there's any electrons do it more than protons do it, or some way like that. It's not going to be a force that's affecting electrons more, like electricity, for example, or charge in general. So, gravity is made of charged elements, but they're not in a segregated. You can't see the charge. The charge it's purple. Okay, the charges are blue and red. The magnets are blue and red. Gravity is purple. All right. You often demonstrate them in blue and red to assign them positive and negative. Yes, and like I say, gravity's a purple force, a purple phenomenon. What you say about gravity makes so much more sense than warped space or the futile search for the graviton. Well, if the graviton wasn't, what they had turned it into, which is a pull particle, right? They're trying to turn it into a pull particle. So if they understood the graviton as being a push particle, then it would work, because then they could say, yeah, and charge has got blue and red gravitons. There's just two kinds of graviton, blue one, red one, and that matches with electrons and protons and creates the inverse relationship. Anyway, example, your way explains how the moon still would have a small gravitational effect on the Earth. Well, I think that was known. I mean, Newton knew that. But again, his assumption is the sun is 1,000,000 times bigger than the Earth. I mean, it's such a diluted amount of movement that the Earth could create in the sun that it wouldn't be of any consequence. And the same thing for the other planets. I mean, in theory, yeah, I would still argue that Newton should have accounted for Mercury's precession by recognizing that the center of the sun's gravity is not static. But I guess they were just so overwhelmed by the fact that the sun is in, this solid thing in the center. That it never occurred to them to realize that that solid thing, although it looks like it stays in one place, that the inside of it is kind of warpy and thick, and there's thick pieces and thin, and they're moving irregularly, and that the center of the gravity of the sun isn't some tiny little speck in the middle of the universe that just stays in one place. This center of the sun is the calculatable, mathematically accurate truth is that the center of gravity of the sun is moving, based on the tidal forces created by the planets orbiting it. All right. Let's see. Where was I? Sorry. Example, your way explains the moon would still have a small gravitational effect on the Earth, while with Einstein, the moon's warping would never overcome the bigger warping created by the Earth to be able to reach the Earth and have a small effect. I don't think that's true. So the numbers are the numbers. So that really doesn't, like I said, Einstein's math doesn't change the Earth's orbit any. There's no effect. There's no advancement in understanding outside of Newton. I mean, once you get outside, really close to the sun, Einstein's math becomes irrelevant. It doesn't mean anything. And again, I would just argue that Einstein's math isn't really using time dilation as the factor that's moving or processing the sun. He is really using sun precession. He's just used time as a way of adding that extra component of uncertainty in the sun's position, if you could say that. And that's all. And again, if it were true, I'm just saying that the logic is quite solid, that you can come up with a mathematics that'll work for Mercury and it won't work for Mars, because the distance is so great between the two orbits that the fact that the sun is wobbling a little bit can't be felt enough by Mars to affect its orbit. But it can affect Mercury because it's so friggin' close. So that's so the Einstein, and again, the truth is that Einstein knew what his math had. He knew the question his math had to answer. So he knew the answer he had to come up with. He knew the number, right? I mean, you can calculate the irregularity of, and Eddington had already done this. He'd already calculated how much the Mercury was irregular. And all he's really saying to Einstein is, show me your math predicting that number. And so Einstein took 6 months with Max Planck, and he came up with a wacky formula that predicts the number. And the catch had to be it can't screw everything else up. So it had to be a system of math that did have this idea that the closer you are, the more you're affected by this process, whatever it would be. But I'm just saying, Einstein's math is so convoluted, I can't even describe what he's doing in it because it has matrices and all kinds of, all this bizarre stuff in it. So I haven't seen anybody rationally describe exactly where, well, this is the time dilation factor, and this is, so who knows? I mean, I'm just saying there's reason to be suspect that Einstein's his formula is actually some sort of efficient, concise method of recognizing what the real effect is. And I've seen real hardcore mathematicians on forums arguing with each other about this very fact, that Einstein's equation is really just accounting for the effects of the rest of the solar system on the sun. All right, anyway. The moon's warping would never overcome the bigger warping. Okay, what do you mean bending? It's not use the word warping. But anyway, bending of space by the Earth, small effect. The way you explain gravity also works and explains the relationship between gravity, mass, and the distance between two objects. Well, I'm just saying the inverse square law is solid, and that can just be understood by, making the circle bigger. You're taking a certain amount of tape and you're going to put it, or you have so much ink in a pen. You have just enough ink to make a circle this big. And if I require you to make a circle this big, you have to use a lot less ink going around. And if I make it this big, it's a lot less ink going around, All right, Einstein knew the relationship and drew them geometrically so it works, but then claimed that the geometry was the explanation for why it worked. Well, that's okay, maybe. To me, more of a con than science, and the fact that it was just accepted by all the top physicists is maddening. Well, and the fact that they still don't recognize that what really launched Einstein was the New York Times headline saying Einstein right, because of the Eddington experiment. And the fact that they just really haven't proven this photon being bent thing. It's really not been proven. I mean, there really isn't any solid evidence in terms of the evidence isn't anything like, taking a picture of chalk and saying, see, there's gravity. There's gravity working. I got a picture of it. We don't have any kind of evidence like that for any of this photon bending theory, because all of the interstellar images have huge mathematical flaws in them, making them all kind of suspect, very suspect. And again, the Eddington experiment's never been successfully reproduced with any kind of better or improved technology, equal or better technology. All right, Einstein knew blah, 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 blah. Yeah, we did that. Explanation why it worked. To me, it's more... Okay, we already did it. Physicist maddening. Do you know of any experimental evidence showing that space warps? Well, obviously I don't. And obviously, yes, I do, in the sense that all the experiment of evidence indicates that if I'm going to call the force space, okay, then fine, yes. There is a force in space, and it makes what could be drawn as a gravitational well. If you want to draw the inverse square law, this is what it's going to look like, okay? It's going to look like one of those kind of parabolas. and it'll make a little well, around the object. So if that's what you're doing, you're going to, make the inverse square law by drawing eccentric circles, right? It's going to look like a funnel. If I draw a bunch of circles proportionally, this circumference 4 times bigger than the previous circle, and I just keep doing that, it's going to look like a funnel. But it's not. There's nothing funneling anywhere. Okay, it's just a change in the amount of force. And that change can be easily understood as an external pressure, because an external pressure will do exactly that. It's exactly the effect it's going to have on something. The photon rays concentrate as they get closer and closer to you. There's more and more of them because you're a smaller and smaller object. It's just the same thing. I mean, you can think of gravity as going out, or you think you're going in, but I just mean all you're really saying is I'm this big and I'm getting hit by a certain amount of stuff. Well, guess what? I can make myself this big and I'll get hit by the same amount of stuff. Yeah. So obviously the amount of stuff hitting me per square inch is going to be huge when I'm this big versus being this big. But from the universe's perspective, it's going to hit me with the same amount of stuff. The stuff that's going to go through my center of gravity will be the same amount. To be more accurate. All right. Do you know of any evidence to me? I also think Einstein's time dilation is bogus but I'll save that for another day. Well, I think the fact that you can break clocks, like I said, you can break atomic mechanisms, so you can rip them to pieces. I was thinking this. Here's a test, right? You can think about logically. Say if they did accelerate you to half the speed of light. The tricks, all kinds of things would be impossible in some respect, right? Because, all right, your heartbeat. Your heart beats because an electric impulse runs down across it. Okay, it moves from the top and moves down across it and contracts the muscle. So it has a direction. So let's say I accelerated you with you standing straight up, right? Then that force, okay, now the matter, your heart is moving. Okay, it's moving towards the direction the force is coming from. So it's like a light bulb shining and you're moving towards it. It's just a simple fact that you're going to get to it much faster, right? So it's going to certainly change how your heart would beat. But, in the inverse, if I put you upside down and do it to you, then there's a real problem, right? Because now your matter is running away from the electric current. So it's obviously can't beat the same speed, anywhere near the same speed, because you've totally broken the way it travels. And inversely, it's ions, so it goes both directions. I mean, the current goes one way, and then the going back to neutral, or it goes from positive to negative. So it goes from being charged to discharge, charged to discharge. It always has to discharge before you can charge it again, that kind of thing. But anyway, all those functions would be broken. I mean, there's no denying they would have to fundamentally change. So that's time dilation, is that systems don't work the same way when they're at velocity. And that should be the simple, everyone should be able to understand that. Unfortunately, they can't for their obstinate, stupid reasons. All right. Keep fighting the good fight and don't get discouraged. Well, I know, but your own comment was, well, anyway. Because it's a fight to overcome the bias towards anything Einstein, and I think you're on the right track. Well, the joke is that they have no respect for Einstein. So I wish they would actually promote Einstein in some respects, because Einstein knew it was an incomplete theory. He knew this stuff really wasn't right, and he was looking for a better answer. So let's not be fooled that Einstein said, oh, yes, this is all just great. That's not what he was thinking. And he made pretty sarcastic statements, late in his life, like 2 years before he died, saying, I've been studying photons for 50 years, and I haven't improved my understanding one iota. I mean, it's a pretty impressive statement of humility, So, pretty much saying, you know, this game is a long way from written for writing in stone. And of course, he had all kinds of disagreements with what science did to his theories. The whole, you he's making a joke. He's making a joke about, well, the consequence of your theory is particles are entangled. I mean, that's silly. And they turned it into a fact. I mean, they blamed Einstein for Einstein invented entanglement. He invented it as a joke. He was saying, well, why don't you just make up a multiverse now? Why don't you use multiple universes to explain where all the energy goes? Because all these things are taking all these paths. Well, instead of having to retract all of that energy, because you took all the paths, right? You went everywhere. And instead of retracting all that energy, we'll just pretend there's a new universe in all those paths. All those paths created a new universe. There, that solves the problem. I mean, you could do it as a joke. And they turned it into a theory. So, it's really not Einstein's fault that they're putting Einstein's name on a bunch of crap that Einstein would be like, God, he'd be really pissed that he's being blamed for it. Like gravity waves and measuring half the distance of a proton. I don't think Einstein would be at all pleased to have himself associated with that crap at all. Or even the whole Standard Model. I don't know what Einstein's opinion was of all these mushy particles. They gave names to a bit of energy. They really don't know what the energy is, but they gave it a name. I mean, it's a little bit just too silly. All right. Oh, we have some replies. Let's see. Exactly. Well, I don't know if it was an exactly kind of comment, but okay. I'd say the EM model of the two forces, two particle type models are actually quite different. Yeah, I mean, well, like I said, there's a certain, I would like to be able to just say, oh, look, Maxwell divided it, and there's really, but his division is based on the distinction between monopoles and dipoles, and my distinction is the distinction between plus and minus. The two forces are related to the creation of charge, not to the creation of magnets. I mean, charge, incidentally, when you make dipoles, you make magnets. That's how it works. DraftScience model works, can be drawn, and can be easily simulated, not to mention matches with many things we actually know. I would say time dilation is something where it depends on what you mean by it. The way most people think of it, they believe time itself somehow is warped. Yeah, they think, too, that, like, say if you were to do one of these experiments, right, and you're time dilated, they sort of have this impression that you live 1,000,000 years. No, when you're time dilated, you're frozen. So everything moves really slowly, right? And so you're not really living any longer, because you're moving so so much slower. And so you're not gaining anything by being time dilated. And you're still aging exactly the same, theoretically. Now, obviously, I would argue that there's no little line you can draw and everything works on that line. Every clock breaks in a different way. Every functional break in a different way. And I would argue that atoms start falling apart at much lower speeds than the speed of light. All right, anyway. Simulated, not to mention matches with many things we actually know. I would say time, okay, depends on what you mean by it. The way most people think of it, they believe time itself somehow is warped. All we can really do is slow down the clock or whatever animated thing by forcing its parts to move a longer distance. It's just multitasking, right? Some things will can accomplish multitasking. Some things can't. If we were to make ourselves more stationary in the absolute sense, stop the Earth from moving, our events would speed up. Not that we would notice, because our clocks and brains would speed up too. Yeah, well, I would sort of argue that that's the unknown. Is, like I said, whether you can apply universality to even the notion of a clock. The atomic clock is an atomic mechanism based on decay, and decay is being caused by what you could argue is a rare event. So atoms decay based on a rare event. They have a vulnerability, and every now and then, every 10,000 years for some atoms, the rare event will happen once every 10,000 years on average. So it's a very rare event, but it's an event. It's like two fingers hitting each other, and they mostly miss. Like there's 15 miles of places you could meet the two fingers, and the only, and the atom will decay when the two fingers actually hit each other. So in 1 mile of finger interaction, you could understand that the two fingers actually hitting each other, when they're randomized, would be very rare. All right, so, and all you're doing is changing that event by giving something velocity. What you're doing is making less interactions, so there's less fingers trying to interact, and therefore you have less probability of the fingers interacting, or you're moving the system, whatever it is, and that's making the unlikely that the fingers interact. So each clock break's different. There's no general statement that can be made that all structure is equally time dilated by velocity. The real concept is every physical structure, every atom, for example, would be affected differently at different speeds. So what happens to one kind of atom won't happen to another kind of atom until a much higher speed. All right. I wasn't really trying to push for EM model of gravity, which I think involves electrostatic charges and builds on the work of Maxwell. I don't think there is any EM model of gravity, so that's the whole problem. There isn't any quantum mechanical. EM is quantum mechanics, okay? The interaction between charge and electrons and protons, that's quantum mechanics. I was just wondering, since EM waves are everywhere in the universe and are composed of two distinct parts. Well, see how you keep saying they're there, so that's part of what I don't like about your statement. There's no evidence that EM waves are anything anyway. There's no whatever. So you're almost conceding that their theory is right, and I don't. What's your reasoning? They got it wrong. They don't have it right. And Gary's model has two distinct parts coming from everywhere in the universe. If a connection could be made, it also seems to me that the oscillations of the EM waves could be viewed as separate pieces. Well, again, you're trying to force fit the two things. I don't see any reason to do that. EM wave is just silly. You can again, you got to understand that the thing is made out of particles. The photon is an individual photon. It's not a waveaton. It's a single frequencies, okay, a precise frequency of events in a row, and the wave is a little bit thick, couple thousand atoms worth of polarization, okay. It's created as a strip, like linearly. So on a piece of matter, the photon is created linearly, and so it when it's flipped up, it's like saying, okay, it's going to be created over a surface of electrons. And this surface of electrons is going to go bip, 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 right? And essentially it's going to send it out like that, it's like pushing it out. And so the stuff that went first comes out at the same time as the stuff that goes last because it's traveling more distance, it's those kind of arguments. So that's why it's polarized. It's in a, this, and it's long. So it has a thickness in one dimension and it has a length in one dimension. But this wave conversation is just so destructive to understanding. The waves are not elemental; they're emergent. Okay, could be viewed as a separate pieces separated by the intersection points. Whatever those pieces contain photons, or could be viewed as photons, is beyond me. Well, whatever. Whatever. I don't see any point in this, frankly. Yes, I know. E equals HF. No, it doesn't. So again, that's complete rubbish. All right. Frequency isn't energy. Frequency is only energy in the circumstance of interacting with are pushing electrons out of their state. So if you want to perturb an electron enough to move the electron into another atom or something like that, you have to hit it with a frequency because the electron rebounds. So the only way, the force has to come at a higher frequency to be able to get it out of there, to tip it out of its tension. And that's the only circumstance where this is true. All other energy is just the fact that you did actually move an electron, and that, you created imbalance in a system. And so the rest of the energy is just about balancing systems, tilting them. And that energy has nothing to do with frequency. But Gary's model makes sense, and I like things to make sense instead of having to accept space-time as a way. Well, you shouldn't be accepting wave time either, as a way it is with little or no evidence. Einstein said gravity affects time, and I had a professor give an example of a man and his clock on top of a mountain experiencing time faster than a man and his clock at the base of the mountain. Well, that's the ironic part. Is that the lower you go, the more gravity you're in, and so therefore the more time dilation you experience. So, it's exactly inverse to what people think it is. But the real point is that y is more gravity equal to more velocity. Because the real connection is it's velocity that causes time dilation. You don't have to be accelerating. All you have to have is a velocity. Velocity causes it. What do I want to say about that? So it's really just about traveling more distance in a moment of time, and that's all the whole thing is really about. And how much distance you cover is really how fast you're going. So obviously, if you're bouncing in higher gravity, you're bouncing a lot more, and therefore covering more distance. You're dribbling faster. He said the atomic clock was more accurate. Let's see, atomic faster versus grandfather clock slower. He said the atomic clock was more accurate. Obviously, again, some clocks break really easy. You can break a sand dial just by, turning it sideways. Don't work no more. Some clocks break really easy. I said, but a day is the exact same for both, and the year is the exact same for both. I never got a good answer to that. Well, you just won't. The truth is they're going to say that on top of the mountain, you age faster, and so the clock on top of the mountain gets old. It'll be, when it's 10 years old, it'll look like it's 20 years old. That kind of thing. Obviously the amount of time dilation is so slight between those two circumstances that you really can't see that a year isn't the same for both of them, in the sense that one of them actually experienced a lot more actions, it had more interactions, and the other one had fewer interactions. And so one of them's way behind in terms of living. It's just living slowly, so it's not moving along. All right. Let's see. One more. Good points and good observations. There's also less atmospheric pressure and some increase in conductivity. It's a decrease, but anyway. What is there to say? I guess that's enough for a video, right? I don't know if there's any point in doing this thing. I'm not feeling the fun. How good is the evidence for dark energy? Well, we just listen to the beginning of it and say, ugh, what a cruddy, stupid subject.
Hello everybody, today I'm visiting the University of Oxford where I'm talking to Zubir Zakar, who's a professor for theoretical physics, and I've told you about him before because he wrote this paper about the supernova data that may not provide the evidence for dark energy that we thought it was. So maybe we can start with that. So in 2011 a Nobel Prize was awarded for the discovery of dark energy based on the supernova data. And you and your group, you have been reanalyzing the...
Yeah, well, that ought to be interesting. Maybe it's just how, oh, you mean they gave Nobel Prizes for kind of bullshit statistical analysis. So just, this is the same dodge, right? They do this convoluted bullshit science, based on all this, again, assumptions. What does redshift mean? What does this mean? What does that mean? What is, and it's, who knows if any of this has any integrity as real, as something real. Anyway, yeah, it just seems way too. This will be way too complex a subject for a off the top of my head video, so we'll just say maybe another time. I just don't think dark energy is at all. This is the stupid energy that's supposed to be making the universe expand, right? So you have gravity pushing the universe together and dark energy pushing it apart and dark matter pushing it in. It's just too silly. I mean, it's like somebody making a recipe and they, oh, I put too much sugar in. Oh, I'll put some more salt in. Oh, too much salt. Oh, I better put some more sugar in. And they just make a mess because they keep trying to compensate for the wrong ingredient they put in. Not by removing the wrong ingredient, but by just putting some compensating ingredient in. So anyway, enough of video, I think. Feels like enough. It feels like this. What do they call that? The longest march or something, or the this trail of tears. That's what. Yeah. Ugh. You're just gonna die in this desert of stupidity. Anyway, until the next time.